All right, this next video is going to kind of introduce lesson 3.6, located on page 375 in your Quantway core textbook. And it's also going to kind of cover number one. We're going to do number one together. All right, so in lesson 3.6, just like in our previous lesson, we're going to be dealing with a formula. So let me give you a little background on what that formula is talking about. So what it's talking about is alcohol consumption. So, and very specifically, alcohol consumption as it relates to driving an automobile. So, most of you are probably aware that 0.08 in some way indicates a level of alcohol that's too high to legally drive an automobile. And this here is a little ad campaign that I found off the internet. And so what that 0.08 means, so if we just saw 0.08 by itself, we might think, you might not unreasonably think, well, that looks like a decimal, and so I'll just convert it to a percent by moving the decimal point over 2 spots. Well, as it turns out, that 0.08 is already a percent. That 0.08 is already a percent. So that's a really small amount. So think about what that means. So to convert a percent to a fraction, to put this in perspective, we just put that 0.08 over 100. Just like we'd put anything over 100 that has a percent sign after that. So if we wanted to get rid of that decimal, we could move it over 2 spots, but then we'd also want to move it over 2 spots on the bottom. So what that means, I'll write this over again neatly, that's 8 parts out of every 10,000. So if you have 8 parts out of every 10,000 in your blood is alcohol, you're too drunk to drive a car. So percentage-wise, that's very small, but it does its job very efficiently. So just a little background, there's some other percentages here in New York State that are worth noting. So if you're under 21, in other words, when you're technically too young to be drinking legally, they have something called a zero tolerance law, which makes it illegal for you to drive with anything over 0.02% blood alcohol content. So if you're underage and drinking and driving, it doesn't take much alcohol at all for you to get in some pretty big trouble. And there's a sort of level for adults below DWI. So 0.08, if you drive, if you get caught with a blood alcohol content of greater than 0.08, you get a DWI conviction, which stands for driving while intoxicated. If it's a little bit lower than that, but still above 0.05%, you get a DWAI, or driving while ability impaired. They also up the penalty if you're driving a commercial vehicle. So that's like a bus or a truck of some sort. And I imagine that because those vehicles are much heavier and have the potential to do more injury and damage, that they cut that limit down to 0.04%. 0.04% if you're driving a commercial vehicle. So there's a higher level of DWI, just like there's a lower level of DWAI. There's a higher level if you're above 0.18%. If you're above 0.18%, you get something called aggravated DWI, and that has a higher penalty and is a more serious offense, because by that point you're pretty intoxicated. And lastly, and this of course varies by individual based on various factors, but in general, if 0.40% of your bloodstream is alcohol, there's a very good chance that you will not make it to see the hangover from that particular experience. You'll be dead. So the way that this blood alcohol content is typically measured is either with a breathalyzer test. They can measure the alcohol on your breath, or by taking a blood test. And those are inarguably the most accurate ways. But just like with the braking distance from the last lesson, there's a formula that can help us approximate it. And that's what we're going to be looking at today. So this here is the formula reproduced from page 376 in your textbook. Let me just go over what these different letters mean here. This B stands for blood alcohol content, also called BAC a lot. And this is in its percentage form. So if we're talking about the 0.08 the percent that you need to get a DWI, that 0.08 would be the type of number that would go right where that B is. So that's a BAC as a percent. So T is time, or the number of hours since you started drinking. That's the number of hours since you started drinking. So this N over here, this N is the number of drinks that you've had. And by drinks, I have a little graphic down here. One drink is equal to a bottle or a can of beer, a glass of wine, or one shot or cocktail of including hard liquor. So that's the number of drinks that you've had. This W here, this W down here, is the weight of the person doing the drinking in pounds. And this R is something a little unexpected. This stands basically for the absorption rate of the alcohol. Now, this talks about this, a lot of that, this varies from person to person. But the biggest thing that causes a variation in this absorption rate is your gender. So for R, for males, it is 0.68, and for females, it is 0.55. So these you'll just be given, you won't have to plug them in. And these are just average values, but these are average values for men and for women. Okay, so number one asks us to think about why the items, or by the variables on the right of the equation, make sense in calculating the BAC. So this 2.04, I didn't mention it before, but these two numbers, we don't really need to think about it because those are just part of what make the formula work. But what we're interested in is why the variables make sense on the right side of the equation. So let's look at them one at a time, and let's start with time. So over here we have time being multiplied. This is the number of hours since you started drinking, multiplied by a negative number. That's what that means. We're being multiplied by a negative number. So the bigger the time value, the bigger the value of t, the bigger of a negative number you get. So adding a bigger negative number to something means the end result is smaller, right? So if you start with a given number, the positive number, the bigger the negative number you add to it, the smaller and smaller you get. So that makes sense, right? Because when t is bigger, which means when it's been more hours, then that means that b is smaller. And that makes sense. Okay, let's look over here at this next bit here. And what we have is a great big fraction. So I'm going to go off to the side and do an example here to kind of refresh everybody on what happens with fractions. So let me write two fractions over here. Let me write 3/10 and 5/10. And again, these aren't a direct connection to this equation we're working with, but it's illustrating us a point that will help us understand that equation. So which of these is more stuff? Would you want 3/10 of your favorite pie or 5/10 of your favorite pie? Well, clearly 5/10, right? Because 5/10 is more than 3/10. So when you make a numerator bigger, Okay, so we'll come back to that example in a second. So our n over here, that tells us that when our n gets bigger, this whole big fraction here itself is going to get bigger. So that makes sense, right? When n is bigger, then your B, your blood alcohol content, is bigger. The more drinks you have, the more alcohol you have in your blood. So that makes sense. So now we're looking at the bottom of the fraction. So let's think about the bottoms of fractions. So let's start with 5/10 over here. And then let's think about 5/20. So in this case, I've kept the same numerator. The 5 stayed the same, but I've made the denominator bigger over here. So this second fraction has the bigger denominator, but which fraction is talking about more stuff? Well, clearly this first fraction over here, this first fraction, 5/10 of a pi is half of a pi, but 5/20 of a pi is only a quarter of a pi. So as your denominator gets bigger, the overall fraction gets smaller. So that's what's going to happen over here. So let's see if this makes sense. That would mean that if W gets bigger, then B is smaller. So W is weight, so it makes sense that a heavier a person is, the more alcohol they can drink before they get drunk. So that makes sense. So here comes the R, the one that kind of is the least intuitive. So what this means is the same as W. When R is bigger, then that means B is smaller. So let's remember what R means. R means that for men, it's 0.68, and for women, it's 0.55. So what that means is that when R gets bigger, in other words, if you're a man, your blood alcohol content is smaller. So believe it or not, women physiologically get drunk faster than men, assuming their weight and the number of drinks is all equal. All right, so that was number 1.